There's this very specific feeling you get when you're learning something hard.
Oh, I know what you mean.
It's that phase where you've done the reading, you've watched all the videos, you get the theory.
Right. In your head, it all makes sense.
But then you actually sit down to do it, and you're just banging your head against a brick wall.
The plateau of confusion.
Yes.
That's the absolute worst. You feel like you're just spinning your wheels.
Exactly. It feels like static noise. But then, and this is the best part, this is what we're all chasing, something just shifts. You're washing the dishes or walking the dog, and suddenly, snap.
Uh-huh.
The fog just lifts,
Yeah.
and the chaos suddenly becomes a system. And today, on our deep dive, we're not just talking about that feeling, we're going to witness it happening to someone, kind of in real time.
We're digging into a source that was published, today?
Literally today, Friday, February 6, 2026. At first glance, it looks incredibly niche.
Uh-huh.
It's a blog post titled, Notes on Haskell Programming, Part 51, Managing I/O, Return Values with Void.
Part 51. Okay. That number alone tells a story.
It really does, and that number is going to be critically important later.
Nice.
The author is a developer named Ang, who goes by Kian Meng online, and he calls himself an old software plumber.
I love that. Plumber. In tech, everyone's a ninja or an architect or a wizard. But a plumber, that's someone who gets their hands dirty, who fixes the leaks, makes sure things actually flow.
It's humble, but it's essential. It suggests he's seen a few things, right? He knows where the pipes are buried.
Totally.
So our mission today is kind of twofold. First, for the coders out there or just the curious, we are going to unpack the actual technical problem he's solving. It's all about Haskell, strict types, and, well, how to elegantly throw away data you don't need.
And it is a genuinely elegant solution.
But the second part is the human story. It's about the sheer persistence it takes to get to that aha moment. Because Ang didn't figure this out in part 1 of his series.
He figured it out in part 51.
Exactly. And that context changes everything.
It really does. In a world of learn to code in 24 hours, seeing the long game. It's just so refreshing.
So let's grab our wrenches, set the scene for us. What's the actual headache here in Haskell?
Okay, so to get the headache, you have to understand that Haskell is a bit of a strict disciplinarian as a language. It is obsessed with types.
Right, and types are just labels for data, like this is a number, this is a word, that kind of thing.
Basically, yeah. But Haskell goes a step further. It cares a lot about the context of that data. Like, does this data involve interacting with the messy outside world?
Printing to a screen, reading a file.
Exactly. Listening to a keyboard. If it does any of that, the data gets wrapped in a context called I/O, for input-output.
It's like a hazmat suit for your code. If you touch the real world, you have to wear the I/O badge so the rest of the pure code knows what you've been up to.
That is a perfect analogy. The pure code does not want to get infected by all that unpredictability.
Okay.
So here's Ang's situation. He's building a console app. In a previous post, he wrote a function, parse CLI.
Command line interface. So its job is to look at what the user typed in and make sense of it.
Correct. And if you ask a function to parse arguments, you expect it to. Well, to give the arguments back. So its type signature, its label is IO args, it does an IO action, and it returns args.
Seems perfectly logical. I ask for arguments, you give me arguments. What's the problem?
The problem, the conflict, happens when you try to plug that function into your program's main function. Main is the boss in Haskell, where everything starts.
Okay.
And the boss doesn't report to anyone. The main function is just supposed to run the program and finish.
Yeah.
It's not supposed to hand a value back.
So the boss expects nothing.
Technically, it expects unit. In the code, it just looks like a pair of empty parentheses. It's Haskell's way of saying void or no meaningful value. The standard signature for main is IO.
Oh, I see the problem now. Ang has this parse CLI function that's proudly holding up its args saying, here, I found the data for you.
Right.
But main is looking back at it saying, I can't hold that. I'm only allowed to hold unit. I can only hold nothing.
Exactly. It is a classic round peg, square hole situation. Now, in a lot of other languages like Python or JavaScript, you could just ignore the return value. You just not use it. The computer wouldn't care.
But Haskell cares.
Haskell cares deeply. The compiler will scream at you. It says, hey, these types don't match. You promised me IO unit, but you're giving me IO args.
Yeah.
So he's stuck. He needs to run the parser, obviously, but he needs to somehow intercept that result and just throw it away before it gets to main.
Precisely. He needs to separate the action from the result, keep the side effects, but make the return value vanish.
And this is where the hero of the story comes in, a little function named void.
Yes.
Yes.
Void. It comes from a standard module, control.monad. And for a software plumber, this is the ultimate tool.
So how does it work? Is it just like a magic eraser?
Close. Think of it more like a filter. You
Yeah.
wrap your function, parser in this case, inside a void.
Okay.
The void function lets the action happen. The computer still reads the command line. It does the parsing work. The side effects, they still happen.
So the plumbing still flows. The water moves through the pipes.
The water flows, yes. But void catches that return value, the args object, and just disintegrates it. It replaces it with that empty unit.
It runs the code, but it suppresses the receipt.
That's a great way to put it.
Yeah.
The transaction happens, the receipt gets tossed, and now the result of the whole operation is just I/O.
Which is exactly what main wanted all along.
Exactly. Everyone's happy. The types match. And the Kohi shows it's just so clean. It's just main prod void CLI.
So satisfying. But Aang doesn't just stop there. He does something I think is really valuable. He compares void to another function, return.
Or pure, yeah. This is where you get into the philosophy of it all. If you've ever touched functional programming, you know return. Its job is to take a raw value, like the number 5, and wrap it up inside a context. It lifts the value into the box.
Return packs the suitcase.
Right. And Aang points out that void is the opposite. But it's a specific kind of opposite. It doesn't take the value out of the box. It keeps the box, the I/O action, but it empties the contents.
I love that. One puts the treasure in the chest. The other keeps the chest, but dumps the treasure overboard.
A little wasteful if it was actual treasure. But in programming, getting rid of unused stuff is crucial. If you don't do it explicitly in Haskell, the compiler thinks you made a mistake.
So using void is like telling the compiler, no, I'm intentionally ignoring this. I know what I'm doing.
It's all about intention.
Very cool. Now, before we get to the human side of this, he gives a warning, a trap. And this is something I would 100% mess up.
Oh, the classic naming things is hard problem. Aang points out that there's a huge difference between void the function and void the type.
They're spelled the same.
Spoken, yes. But in code, the case matters. The function void, lowercase v, is the utility we just talked about. It discards values.
Okay, the trash can. And the other one?
The other one is void with a capital V. And this is a weird one. Void is a data type that has no values.
Wait, how can a type have no values?
Yeah.
Even 0 is a value. False is a value.
I know, right? It's a total mind bender. It's a type that's logically impossible to create. If a function asks for a void type as an input, you can never, ever call that function.
That's existentially terrifying. It's a door that leads absolutely nowhere.
It's a black hole in the type system. But the point is, if you mix them up, if you use the black hole type when you meant the trash can function, you're going to have a very bad time.
Wow. It just shows how vital that precision is. You have to know exactly which tool you're grabbing.
Absolutely. So we've solved the puzzle. We used void, lowercase v, to fix the types. But this is where the story really takes a turn. Because usually a coding tutorial just ends there.
Right. Here's the fix. Thanks for reading. But Aang adds this personal reflection. And this brings us right back to that aha moment. Let me just read this. He writes, "While drafting this post, it has finally dawned on me how type signatures and contexts actually function in Haskell."
That is just. It's so profound. Think about what he's saying. He isn't saying he learned a cool trick. He's saying the core concept of the entire language finally clicked for him while writing this post.
Part 51. And he even puts a timeline on it. He says, "It has certainly taken some time, nearly 50 posts, around 1.5 months, just to reach this moment of clarity."
50 posts.
Yeah.
Just let that sink in. That's more than a post a day for a month and a half.
It just completely validates the struggle, doesn't it? I think we all assume that experts just get it instantly. But here's a guy, an old software plumber, admitting he had to write 50 journal entries to finally understand a basic concept.
It's the difference between passive and active learning. He wasn't just reading, he was writing. He was forcing himself to explain it, struggling through it publicly in Part 10, Part 30.
And probably feeling stupid for a lot of it.
Almost certainly. That's the vulnerable part. But that process of trying to explain it, of writing it down, that's what forces the understanding to happen.
And his attitude is so calm about it. He says, "Nevertheless, we shall continue to take things slowly and progress steadily, one post at a time."
One post at a time. That's the mantra right there. People overestimate what they can do in a day, but they underestimate what they can do in, well, 51 blog posts.
Speaking of which, we have to talk about the sidebar on his blog.
Oh, the sidebar. This is where the profile of our software plumber just explodes with color. This is where we see that Part 51 isn't an anomaly. It's a lifestyle.
So I'm looking at the projects list on his site, and if you think notes on Haskell Part 51 is dedicated, guess how many notes he has on gardening?
Gardening. I don't know, maybe he's really into it. Part 100.
Try Part 799.
No, you're kidding. 799.
I am not. Notes on gardening, Part 799, the practical evaluation, and right before that, Part 796, the case for red trumpet vines.
That's incredible. That's years of documentation. That's observing seasons, plants growing, dying, regrowing.
It doesn't stop. Notes on fish keeping, Part 189. He has notes on photography up to Part 228.
And I'm looking at the list here. He's got Elixir, Python, Go, Rust, but then also dieting, home improvement, guitar, meditation.
He's like a modern Renaissance man, but with the soul of a librarian. He documents everything.
There is a clear psychological pattern here. This isn't just someone with a lot of hobbies. This is someone who finds meaning in the process of observation itself.
It's compulsive, but in the best possible way.
Exactly. And it connects right back to the Haskell post. When we see Part 51 and marvel at his persistence, we now see that this is just how he operates. He applied the same rigor to red trumpet vines that he did to the I/O type.
It makes you wonder if that's the secret sauce. Like, does being really into fish keeping make you a better programmer?
I would argue yes, 100% yes.
How so? Fish don't have source code.
No, but they have systems. An aquarium is a complex system of variables, pH, temperature, aggression. Mastering that takes patience, observation. It requires debugging. If a fish gets sick, you have to debug the entire tank.
That's so true. You check the nitrate levels, the filter. It is debugging.
He is mastering the meta skill of learning. He knows how to break down a complex system, an aquarium, a compiler, into small observable notes. Notes on. It's all about observation.
And he's not afraid to be a beginner. That's the other key. You can't be an expert at guitar, fish, gardening, and 5 programming languages at once. You have to be okay with being the new guy, constantly.
And that comfort with being the newbie is exactly what let him stick with Haskell for 50 posts until it clicked. Someone with more ego might have quit at post 10 because they felt stupid. He just kept writing notes.
We love this. Beta spawn logs.
Oh,
research papers to read. It's just this massive external brain that he's built for himself.
It's the garden of his mind, quite literally.
So let's bring it all back. We started with this tiny piece of code, main is void parse CLI, a simple fix.
But to get to that simple fix, we went through type theory, context, and learned that sometimes you have to explicitly throw away what you don't need to make the system work.
And more importantly, we got to look into the mindset you need to actually master this stuff. It's not about being a genius. It's about showing up. It's about writing Part 49 and Part 50, even when you're still confused. So you can finally reach Part 51 and say, oh, I get it now.
And realizing that the tool you use to discard a value, void, is just one small brick in a massive wall of knowledge that you're building, brick by brick.
So here's my question for you listening. What is the Haskell in your life right now? What's that thing you're struggling with where you feel like you're just spinning your wheels?
And are you willing to write the notes? Are you willing to push through to your Part 50? Because that clarity is there. It's waiting for you. But you might have to be a plumber for a while.
And hey, maybe you need to start a notes on journal, whether it's sourdough bread or quantum mechanics.
Just, remember to distinguish your void functions from your void types.
Precision matters. I want to leave you with one final thought. Looking at Ang's sidebar, the fish, the gardening, the code, we always hear that you need to specialize. Jack of all trades, master of none.
Right, that's the old warning.
But looking at this, you have to ask, does true mastery actually come from that cross-pollination? Does the patience from waiting for a betta fish to spawn teach you what you need to debug a race condition in your code?
I think today's source suggests the answer is a resounding yes. Everything connects. The more you pay attention to the world, the better you get at all of it.
Something to think about. Thanks for diving deep with us.
Until next time.
See you.